Welcome. So in this part, what we're going to be doing is creating one-to-one functions by restricting the domain. So how can we restrict the domain of the following function to make it one-to-one? So currently we have a domain of all real numbers, and this is our rule. Let's begin by just sketching what we've been given here. So we're going to come to our CAS calculator, and I'm just going to sketch this rule right here. So let's just move this over here so I can see it as I write it in. It's x cubed minus 4x squared plus x plus 6. X cubed minus 4x squared plus x plus 6. There is my line. So I'm going to give this a sketch. I also want to find out what the maximum and minimum are for certain points. So I want to find the maximum of this point, menu, analyze graph, the minimum of that point right there. All right, let's just move that there. Let's now try to give this a sketch to the best of our abilities. All right, so we're going to go all the way up till we get to there. Then we'll come down till we get to there. And then we'll go back up like that. This point is going to be 2.535 to negative 0.879. And this point here will be 0.131 to 6.065. Perfect. So we have our nice graph here. Now what we have to appreciate is that it's currently not one-to-one. And the reason why is because if I was to draw a horizontal line through it, as you can see, I'm going to have 3 intersection points. So because it intersects more than once, it is not a one-to-one function. So now, how could I restrict the domain to make it a one-to-one function? Well, what if I got rid of this portion of the graph? So now I just have this. Well, if I did that, it's now one-to-one, because if I draw a line, it only intersects it once. So if I make that restriction to my domain, I can get the answer that I'm after. So that means when x is an element of negative infinity to 0.131, I will get a one-to-one function. And it doesn't matter if this is a round bracket or a square bracket. But let's just put a square bracket there. Perfect. So as I said, if we get rid of this part right here, and therefore I'm just dealing with this, when I now draw a horizontal line, it only intersects it once. All right, let's bring back our graph. All right, what else could we restrict here? Well, what if I got rid of this part and this part? Well, now when I draw a horizontal line, it only ever intersects it once. So yet again, I have restricted the domain successfully to make it a one-to-one function. So let's bring that back. Whoopsie daisy. Sorry about that. Kind of freaked out there for a second. There we go. So now I'm going to say when x is an element of, now I want to go from this point right here, so 0.131, all the way to this point here, so 2.535. I'll close that off. Could I restrict it in another way? Absolutely. What if I got rid of these points right here and now just had this section? Well, now when I draw a horizontal line, I only ever intersect it once. So yet again, I've done it. So let's bring everything back and let's write that in. So when x is an element of, this time I'm starting at 2.535 and I'm going to infinity. And of course, there are so many more ways you could do it as well. So for instance, I could say when x is an element of, and we could just say 3 to infinity, right? We could say 3 to infinity, because then it's just starting here, right? 3 would be somewhere there. So if I restricted it so the domain was from that point forward, it would also go on. So there's literally an infinite amount of ways you can do this. So I'll just write etc. there. But it's just important for you to know these major 3 ways to break it up into those 3 sections. But then also realize, we could restrict it so that it's just from here to here, or maybe from here downwards. So there's lots of different ways of restricting it so that it is one-to-one, but these are the biggest ones you can do. And of course, the infinity ones are the biggest ones, and that's the middle one. All right, hopefully that makes sense on how we can restrict the domain to make it one-to-one. Just think about that horizontal line test, and that will lead you to the right direction.